Hey everyone, welcome to Vidyaspace. Today we are going to solve two sum problem. It is a easy category lead code problem, but we are going to see this problem and break down it in different types. So we will be seeing three types. We will see the variations, what are the different variations can be asked in this question and how we can approach towards them. Okay, so let's try to understand the question first. The question is saying that you are having an array given and the target is given. Okay, so we have to find the indexes. Let me just write down the indexes. So this is 0 1 2 3. Okay, so we have to find the pair of indexes upon summing of which we will get this target. Okay, so for example, if I take an pair of index 0 and 2, which is 2 and 7, so 2 plus 7 is definitely 9. So this can be one answer. So the answer would be 0 1, which is the pair of index. Similarly, if I check another pair like 7 and 11, so definitely this and this can not be a pair because 7 plus 11 is not equals to 9. Okay, so given that every question will be having at least one solution or exactly one solution. Okay, so our task is to find one of that pair. So as soon as we get one pair, we will be returning that as an answer and we are done with our algorithm. Okay, so the very first naive solution which will come in my mind, if I think of a brute force logic, so what I can do is I will be running a two loop. So for example, if I have 2 7 11 15, okay, so I can say that I'll start a pointer here I, and then I will check all the positions after it till the last position, till n minus 1 position, right? Because here n is 4, so the index of each elements are 0 1 2 3, so which is nothing but n minus 1, right? So I can run a for loop which will run from I equals to 0 to n minus 1, and I can again start another loop from I plus 1, which is going to be a jth position, right? From here till this direction I will be checking if that pair can give me a summation of 9 or not. So I can run another loop, j is equals to I plus 1 till n minus 1. Okay, and then I will check if array of I plus array of j is giving me target value. I can return this as my answer. We can use a list or we can return a tuple based on the question. So question is asking to return an array, so we can return array with ij position, and that's all. So there is one edge case which we have to think of. If we think with an example, another example here, you see 3 2 4 give an array and target is 6. So if I'll start my I position from here and j position from here, then when I will be at the last position, I minus n minus 1, which is basically the I will be going to be here. Okay, so if I will reach here, then in that case this is the last index which we can have. So j, if we will see, we are defining j is equals to I plus 1. So in that case j will go to n, and this may cause some problem and unnecessarily loop here. So what we can see, we can have a valid position only till the place when my I and j are in the order, right? I is before j. So for this example 2 7 11 15, 2 7 11 15, if I see, so if my I is here and j is here, that is the only final pair which I can check, right? After that, if I will move my I to this position, this is the only last position. After that there is no element. So ideally the for loop for I equals to 0 to n minus 1 will be one step more back, which will be n minus 2 actually. Okay, and then inside this j will be I plus 1 till n minus 1. So this will be the actual loop. Now if we talk about the time complexity for this brute force logic, we are definitely running two loop, right? So if I see here, we are having first loop here, which is going to run for approximately O of n time, because if we have large number, so this will be O of n, and another loop which will again in the worst case can go up to O of n. So for each I we are running a j with O of n complexity. So total we can have O of n square. Why n square? Because suppose if you are at this position I, okay, you are having a 2, 7, 11, 15, 8, 10 like this, and one few more items here, 2, 1. So suppose this is the given array and we have our I position here. Now for this I we are starting our j position from I plus 1, and this j will be moved from this position to next till again next, right, till here 7 till 11, 15, 8, 10. Okay, so this way we will be moving our I and j. Again when our I will move to one step ahead, again j will start from here, then it will go till end like this, and then again it will be done. So then again what happened, our I will move one more step ahead, then our j will again start moving from I plus 1 till the last position, and we will be checking this loop thing until we are not finding our results. So in the worst case we will be going to check entire array, and this I might go till the end position where we have to run the loop till end. Okay, so that is why the time complexity will be O of n square, and we are definitely not using any space. So if I talk about space complexity, we are having zero space complexity, constant space complexity, which will be O of 1. Okay, because we are not using any particular space to solve this algorithm. So for the brute force logic, definitely time complexity is O of n square and space is constant. Okay, so this is the brute force solution. Now, if we think carefully, we can understand this. We have to do little bit optimal. Somewhere we can think of O of n solution. So to come to O of n solution, we will be trying to figure out how can we reduce this second loop. Okay, so to reduce this second loop, we can see that if I am having a position here I, okay, and then j is starting from here I plus 1. So when I am going from my ith position, this j from here to here, okay, let me take a fresh example here, that would be better. Oh. So let's take an example of 3, 2, 4. Okay, so when my I is here, I was starting a j pointer from I plus 1th position, right? So if I want to see a comparison at this jth index, I am checking what is my I, right? So every time when I am moving my j from this current index to the next index, like j from here to here, so we have already visited this particular 2, right, which is a memory we can store, so that we don't have to again pass and again figure out what will be my new pair. So we can make use of this. So what we can do, we can think of a memory storage. So what I will do, I will just have one pointer only, which will be running from 0th position to n minus 1, and I will keep a map data structure ready to have a memoization, to remember what is the previous items visited. Okay, so I will be having a target, suppose equals to 6, and I am having my current index at 3. So I will check whether array of ith position is actually going to give me the value 3, right? So I have to check whether in my map previously visited items, do I have something which is upon summing up can give me this target value. So array of current position is 3. So if I will check, my map is empty, so there is nothing which I can add up here with this 3 and get my target. What I can do, I will move ahead. Before that, I will save this 3, and this 3 is at 0th position. Okay, I will move to the next index. So next index is having 2, so I am here 2. Now I will check for this 2, the current array of I is 2. Okay, and now I will check whether I have a value previously visited in my map which can sum it up to target. So we have to reach target 6. My current element is 2. So we have to check for what? We have to check for 6 minus 2, right? 6 minus 2 will be somewhere near to 4. So we will see that in my map we have only 3. We don't have 4 here, right? So we cannot make a summation with the current visited item and the previously stored item. So we will again move ahead with this position to next position, and before moving that, we will be storing our particular item 2 with the 0th 2 with the index 1. Okay, now we will be going ahead to the next position. So this time our array of I will be 4, which is going to be again 6 minus 4. We will check for 2. So we will see that for this we have items stored in my map at the index 1 position. So definitely this can give me a summation of target. So what we can do, we can just return at this position that array of current position value plus this 2 which is at index 1, array of 1 can give me the target value. Okay, so we can return, simply we can return that the answer can be 1 and the ith position. Okay, so let's write the code for it. So what we can have a function which will be returning an array of integers, and we can name it something like toSum, and we are sure that we are going to get an integer array nums, and we are going to get an integer target. Okay, so what we will be doing, we will be iterating over the nums array. Before that, what we can have, we will be having an for loop I equals to 0 to less than n I plus plus, and n will be nothing but it will be our nums length. Okay, now here we have to also define our map data structure. So we can define based on our syntax logic for any programming language. Here I am just writing based on the C++, but it can be a same strategy. We just have to change the syntax for other languages. So which will be here, like if you see, we can have a map to store the value and index. We will be having a dictionary, and dictionary can be of intent. Okay, so what we will be doing, we will be moving ahead and we are checking that in my dictionary do I have the value array of I, target minus array of I. Okay, so target will be the value minus array of I. We have to check, this is the check integer we have to do. So if you remember, here we were checking, right? So our current index was the 2 here, and then we were having 6 as a target, so we were checking for 4 in our map. Then here we were checking for 6 was the target, 4 we were checking for 2. So that is the thing we are doing here. Target minus current index will be the check value we will do. So we will check that map dot try get value, do I have this check val. Okay, I'll just name it correctly. Let me just correct it here also. So this is nothing but integer check val. Okay, so this check val will be checked if it is having the value inside my map. So we are going to get the index, okay, out as value is going to give me that if idx is not null, okay, then we can do return an integer of size 2, which will be going to have my current idx and I. Okay, if not, what we have to do, we have to continue. Before doing that, what we will do, we will store the checked value, whatever the current value is there. So we were having current value as array of I, so we are going to do map dot add our current value of item and the current index, so that for the next iteration of I, it might can be useful and a valid candidate. And this is where our for loop will end. And in the end, what we can do, we can return an empty array if we have not found and this condition is not hit. So just for the sake of it, we can return an empty array. Okay, that's all. So this will be the function. And if we talk about the time complexity, so we are running a single loop which is having O of n. We are running till last index. In worst case, we might go till n minus 1 index, from I to I equals to 0 to n minus 1. So this can be running for O of n time. And here this map operation will be O of 1. Then here again we are just adding an item in the map, which is again O of 1 operation. Since this is a map which is unordered map, that is why the operations are O of 1. If it is an ordered map, definitely these operations will be log n, O of log n for the ordered map. Okay, so we don't have to use ordered map because that is not at all required for this particular use case. We just want to store the key value pairs. We don't want them to be in any sorted order. So this can be O of 1 for our case. And total time complexity, we are going to have O of n in worst case. And if we talk about space complexity, so we are using a map data structure to store a pair of integer. In worst case, we can store the entire element of the array, which we are doing here, right? So entire element of the array can be stored in worst case, which is nothing but n items. So that is why this can go up to O of n. So total time complexity for this question would be O of n, and space complexity again O of n. This would be the optimal solution. Okay, now this is a one case where we are having optimal solution, and this will be the optimal final solution. There is a slight modification sometimes given in the questions. If you see here, so for the given questions, we are having this array as unsorted or sorted. It is not given that this array would be sorted. So if you see here, this is not a sorted array in the input. Okay, So that is why we have to follow this approach if the given array is not sorted. Okay, not sorted in then only we are following this approach. In some of the cases we have seen that the question will be provided that array is given as sorted. Okay, so if this is specifically mentioned in the question that the given array is a sorted array, then we can make use of one more optimal solution, which will be actually doing a use of two pointer approach. Okay, so that focuses on two pointer logic. So what we can do, we can apply that same two pointer logic in this question also, but before that we have to do the sorting on the array, and sorting on array can go up to n time complexity, which will be not better than O of n. So that is why we will be going with O of n log n in that case. So we will think if the array is given sorted, then what we can do, we can simply take an example that array is given as 2 7 9 15 17, and the target is also given that it will be somewhere near to 16, and we have to do the same operation. So what we can do in this case, we can simply run two, we can take two particular pointer I and j pointer. Okay, one at the start of the array and one at the end of the array. So I will be at the position 0, j will be at the position n minus 1. Now why we are doing like this, we have a target of 16, so we will check whether this ith and jth position from the start and end is giving me summation 16 or not. If I check 2 plus 17 is giving me 19, so 19 is more than 16. It is indicating that in my values which I have taken, the ith and jth position, it is giving me more summation, so which means I have to reduce down this combination sum. So it means I have to take some lower value. So lower value means we have to move the jth position, because if I will move I to next position, the value will going to be increased, because this array is given in the increasing order, right? So if I take 7, the summation is going to be increased again. So that is why it is simply indicating that if the value is going beyond the target value, we should reduce the jth item to one step back, and that will be going to j minus 1, right? So we will move our j position to here. So now, since previously j was higher, now before moving to one step back, we'll reduce the value of j. Now again we will perform a check that array of I 2 plus array of j 15 is giving me summation 17, which is again greater than 16. So we have to again move our j position to one step back, and then we will check for the, hold on, yeah. So what we can do, let me just move it, yeah. So we will be having j here. Okay, now I will check again that whether my current item 2 plus 9 is giving me summation 11, which is now, if you see, 16 lesser than 16. So indeed we cannot move our j position towards this, because that will again reduce the value down from 11, and that is why we will be now moving our I pointer towards right, because we have to increase this value of 11 so that only we can reach to 16, right? So what we have to do, we have to move ahead to one step back, which is here. Let me just do a little bit cleanup here so that we will see the final state of our ij. So my I position is now here and the j position is now here. Then we will again perform a check. 7 plus 9 is 16, and this is definitely equals to 16. So this is our final answer, and our answer will be I and j. This is the final indexes which is giving me target. So if we think how to apply this logic, we can simply have ij defined here, right? I is going to be 0th position and j is going to be n minus 1th position. We can run a loop where we can say while I is less than j, because we cannot go beyond. So if my I crosses j, right, if I goes beyond j or equals to j, we are not going to have any valid pairs, because we have already visited those, we have already compared those pairs. So I will be less than j, and we will check if array of I plus array of j is equal to target, we can simply return it. We can return I and j. If this is not the case, we have to go and we have to say else if we will check if the summation of array of I and j is going beyond target. We have to reduce our j position, right? And if this is not the case, the other would be I plus plus, right? So this while loop will be running, and if this return is not hit, we will return an empty array where we will say array is empty array return, because we have not found any solution. Okay, now if we talk about the time complexity and space complexity of this particular approach, if we see, we are just using a 2-pointer, we are not at all using any space. So we are just having I and j as a pointer, which will go in worst case to entire array items. So if I can see, I will be here, j can move towards this side, or I can move towards right side. So in worst case, we will be moving with all the array items, and we will be visiting at max all array items, right? All array items, not beyond that. So time complexity is going to be O of n, and space complexity will be definitely O of 1 constant space. We are not using any particular space to store anything, so that is why this will be the optimal approach when array is sorted. Okay, now here is something, some few edge cases which we can think of. So for example, if my array is having duplicate items, right? Suppose I'll give an example where my array is 1 2 2 7 5 say, sorry, I'll give a sorted array, right? So let me just a little bit correct it, 7 9 9 12. Okay, and the target is given that you will be having a target of somewhere 7 and 9. Okay, suppose 16 again. So in that case, if my I position is here, starting from the 0th position I, and the jth will be at the end, in this case our first summation will be 12 plus 1 13, which is definitely 13 is going to be less than 16. So our I will move here, I will become here. So again this time, if you see, now my summation is 12 plus 2, 12 plus 2, which is again going to be less than 16, because 14 is less than 16, right? So this time again I should be moving plus plus next direction. But here if you see, if I will check here the ith position, it is also having same item 2, and previously also we have already compared with 2, which was not a answered scenario, which was not an answer, right? So this is not a favorable case where I have already compared this item and the next item is also having the same value. So we should ideally skip this. It is a redundant comparison. We don't no need to do that comparison, right? So we should directly jump onto the 7 with I index and then compare that whether this is going to give me a right value or not. Okay, so this can be a case where we have to skip the particular index. So slight modification in this code, what we can do, we can just do a little bit modification here, that if the slight modification can be here, we can run a loop. We will say, instead of this, we will say in the else if condition that while j is less than n and array of j is equals array of j plus 1, we should move the jth position. Sorry, we are reducing the jth position, my bad. And same goes for the this one also, the else case also, because this for the I case. So we will say that while I is less than n and an array of I is equals array of I plus 1, then we will be doing I plus plus. Okay, that's all. And here again we will be doing a slight correction, where we will be saying j minus 1. So I did some mistake here in writing. This should be array of j minus 1. Okay, cool. So this comparison will be now avoided, and we are only going to do a unique comparison, and if we find a result, we will be reaching. So if you might be thinking that we have introduced a while loop which will introduce a complexity of O of n here and here, and we will having a high time complexity, but let me tell you that this is not gonna be happen, because we are ultimately moving with our I and j pointer to all the index at max 1. If we are here, at max 1 we are moving. So if we are here and here, we are only comparing this position, any two combination we are comparing, right? So if my I is here, that next time that for loop will this while will actually move only to one index ahead, right? Because after that we will be having this thing as the unique item, which was not the previous item, right? So that is where we are actually covering all the indexes at max 1 only. So we will be not having any impact in the time complexity. This is going to be same. Okay, so I think this is it for today. Thanks.